Alright, howdy. This is Sam from the future on this video, and I look back at this video, and I knew when I was recording it I was maybe a little bit aggressive, but looking back, I decided that it was just unnecessary, so my plan is to go back and fix that up and kind of remove some parts that probably don't need to be said and kind of keep just the core concept of what I was trying to say here. Because the main reason why I got aggressive is because there's probably some ego in there for sure, but I would also say that I'm just kind of tired of this argument and people snapping back with such confidence that I'm wrong. And they say things, and I don't think they understand what it means when they say it. And when I had this debate with this person in the YouTube comments, it was clear that they didn't understand the implications of what they were saying. And that kind of frustrated me, because it's like, how do you not see that what you're saying, is contradictory? It's paradoxical. It doesn't work, right? And so instead of being being as aggressive, I will attempt to explain exactly why I have so much issue with this and why I cannot accept the fundamental probability of reality. I can't accept that it's fundamentally probabilistic. I refuse to do that, and it's not because I'm blind to the truth. It's because I don't see how the truth is proven here. There's no evidence that proves that this is true. Just because the math works doesn't mean that the explanation is correct. And so I refuse to accept that it's possible, because, as I will try and demonstrate in this explanation here, I just don't see how you could do it. It's one thing to say that's how the universe is. It's another thing to recreate it. And I just really don't know if you can. And maybe you can. But if we can, I dare someone to try and reproduce the quantum system at a larger scale and get structure to form and get complexity to be consistent. And I doubt it will last. Maybe you'll get it to survive for briefly, but for it to survive permanently, I don't see how it could be the case. And so my explanation here is I kind of had a little bit of a explanation epiphany, and so what I've got is a little drawing that I made here, with some explanations. So there it is. And so what I wrote is, the task I'm assigning you with is build a sandcastle on the beach that maintains its structure and is not washed away by the waves. So what I put here is there's a side view and there's a top view of the beach. The green area is anything that is above waves. So this is what we would consider consistency. We would consider it structure. We would consider it safe. The waves will not hit this location, and therefore if you build a sandcastle above that height in that zone, it is safe. You can build a sandcastle and it will not get washed away. It won't be even touched by the waves, and you can do whatever you want and you don't have to worry about it getting destroyed, right? So that's where consistency is. It's very easy to build a sandcastle there. This task is of no issue at that point. Then there is the point that is the wave zone, where waves are coming up in intermittently in different levels of strength. So we have waves that come up and they barely make it up. Then we have waves that are stronger and then they completely cover the whole area. And so it's a relatively random chance that a big wave comes, right? So you can build in this zone here. And so when a big wave comes is probabilistic. So this is where it fluctuates, right? It's you don't there's no way to predict what the waves are going to be like before you start building your sandcastle, right? You can observe the waves and kind of get an idea of how consistently they roll in, but that's not guaranteed to be accurate 100% of the time. Anything can change at any point, right? It's fundamentally probabilistic when these waves come in and at the strength they come in and all these things, right? So if you try and build a sandcastle here, it will constantly be getting hit by waves and it will constantly be getting destroyed. And so you will constantly have to keep building it, right? You'll have to be building it faster than it can get pulled away. And so, this is where I have issue, right? So it's fundamentally probabilistic. And so that is potentially where the system lies, right? Our universe lies in this wave zone. And then we have the next level, which is just in the water. You're just in the waves themselves. And that is what I defined as chaos, right? Because at that point, like if someone said, build a sandcastle in the water, how do you even begin? As soon as you start putting water in, as soon as you start piling sand into the water, unless you can pile a massive mound of sand all at once, there's just no way you're going to be able to build anything. Because as soon as you pour sand into the water, it gets dispersed and it gets washed away and it goes all over the place. It probably doesn't even make it to the bottom, right? And so this is what I define as the chaos zone. So it is not possible to build a sandcastle, to form structure within the ocean. Whereas in the wave zone, there is a potential chance you can build structure within the wave zone, right? However, it will take the process of you building the sandcastle is one, by pure chance, and two, that it will constantly, you're building it up faster than it gets washed away. Because you constantly have to be adding to it in order for it to be not getting washed away. Right? And so when you look at it from this perspective, this is the universe. This is the system we are told our universe works on. A fundamentally probabilistic thing. You never know what wave is coming next. And so what this means is that since the beginning of time, our universe has maintained its structure because a big wave has not come through. And I just don't see how you could possibly have that be the case. Because it's not that there's no fluctuations happening, right? It's not that the waves aren't big. Like if you were at a lake, I could see, okay, obviously a big wave doesn't really come very often because there's not a lot of waves in a lake. If it's just like, I wouldn't say a big lake, but like a small lake, right? You got a small lake, you're not going to get massive waves in the lake. So yeah, it's not that difficult. But we're not talking about a lake here, right? This is the ocean. These waves are large. And so when you're trying to build right where the waves are breaking, it's not, oh, you're building at the edge. No, you're building inside the zone where the waves are breaking. It's constantly random chance. It's fluctuation. You never know. It might come in and wash away everything. There's a chance that could happen. It's the probability is not zero. And so I don't see how you could form structure in such a system and it not be washed away, right? And the thing is that the way that our current belief is, we do not believe that, like my theory is that energy comes in and is sent out. All atoms are constantly cycling energy. They are not just a solid, unmoving, unchanging thing, right? It's not just that the atoms vibrate. The atoms vibrate because they're constantly consuming and releasing energy. That's my theory. I'm pretty sure that that's not a general consensus, right? We have photons coming in and electrons absorb the energy and then re-emit photons, but that's not the same thing as what I'm talking about. What I'm saying is that at the core level, the nucleus of the atom is consuming and releasing energy constantly. And I don't think that is a general consensus of modern physics. But personally, I think it is a requirement for anything to function. And we see it in all of nature. If something does not consume resources, it dies. Anything that's alive dies if it doesn't consume resources. I don't even make examples. If you can't think of an example where that's not the case, I don't know. So if the current belief is that this quantum fluctuation, this fundamental probabilistic reality is what we're built off of, right? We have these random fluctuations, and then we have these things that just exist, and their energy is inherent, and they're just, once they're created, they sustain themselves because that's just what they do. Because to my understanding, that's what we believe. I don't know what else the explanation is. I could be wrong about that, and we have a better explanation, but I doubt that it's good enough. And so, if you have all of these things that are just, their energy is just innate. Once it exists, it holds that value, right? We have these waves that are, like an electron is seen as just a fluctuation in the electron field or something, right? And the fact that it's a bump in the field is just the definition of it. And it just exists. It can't lose energy because that's just what it is, right? And I don't think that this makes sense. I don't think that this works, because when you have fluctuations, you have waves coming in, you look at your sandcastle and you say, okay, I built my sandcastle, right? And then a wave comes in and washes some of the sand away. But now you can't touch your sandcastle. You can't fix it. So another wave comes in and washes a little bit more of the sand away. And another wave comes in and washes a little bit more of the sand away. And eventually you don't have a sandcastle anymore, because all these fluctuations in the waves has reduced the energy of your electron. And you say, oh no, well that doesn't happen. But the fluctuations are there. They exist. They do something, right? And so I feel like having these random fluctuations happen with our current system, with this fundamentally probabilistic thing, doesn't work. And the problem with my analogy here is that yes, you have these random fluctuations of waves. Who knows what waves are going to come? But something causes the waves to change. When you have a storm offshore, the waves get bigger. When you have more wind, the waves get bigger. Things cause the waves to be this way. The waves don't just change willy-nilly, and it's just whatever they feel like at that moment. There's a cause to the waves, right? But our current belief is that there is no cause. It's just fundamentally probabilistic. And I just cannot accept that something can just happen. I cannot accept that something can just happen, and it continues to just happen in a way that continues to be consistent with our reality. It does not make sense that a fundamentally probabilistic reality maintains stability. And you can say, oh, all these fluctuations cancel out. But I don't think I don't think you can say that. In general, when you take into the grand scheme of the universe, yes, it evens out. But what about in a consolidated area? In a small point? Does it really all cancel out perfectly in every area? So you're saying if we have a +5 over here, there's a -5 over here that somehow gets over here to cancel it out? No. If there's a +5 here, you have an anomaly, right? Well, that's a problem, because that breaks physics. Now physics no longer follows the fundamental probabilistic reality it's built on. What happens then? Oh, it doesn't happen? It never fluctuates past a point of instability? That's a problem. Why doesn't it fluctuate past a point of instability? Why is the probability of reality set within a, I would say, fine-tuned limit? We hate when things are fine-tuned. Why is it fine-tuned? It's fundamentally probabilistic, isn't it? What fine-tuned it? Or we fine-tuned it? Off of what? How? Right? If I told you to build a building, right, on ground that was constantly shaking, can you do it? You would have to plop down prefabricated structure on top of this thing in order to do it. And maybe you could build something, but it is not going to last because it is not sturdy, because the precision you need to maintain a consistent structure is not really achievable with such, oscillations and jerking motion. And so I cannot comprehend a method in which chaos, true chaos, and fundamentally probabilistic reality can become anything but chaos. And I did a talk a while ago that said, what is the difference between order and chaos? And I was like, there's really no difference. And from a certain perspective, this is true. But in the same line, the fact that things are consistent from moment to moment is that is, in the grand scheme of things, the fact that anything is happening can be encompassed into chaos. But from moment to moment, there is structure. Because if there is consistency from this second to this second, right, then we have an impossibility, right? Because the reactions and interactions that are happening at the fundamental level, where it's fundamentally probabilistic, are happening at scales and in quantities that are so massive that for every second the universe continues to work the way it does is an impossibility. The probability explodes to an undefined infinitum number almost instantly. The universe can't exist. And that's kind of gets into my whole thing about how the universe really doesn't exist. But the fact that it doesn't exist is why it can exist, and that gets into a whole complicated thing. But that still comes from a point, that still comes from the concept of cause and effect. And I don't think you can just have it be, right? Because I don't know if I've done this, I don't know if I put this talk out yet, but as soon as you have the existence of something, you can retroactively explain how it happened. And if you just keep explaining how that happened to infinity, you have causality. And so technically, we shouldn't exist. This shouldn't be the case. There shouldn't be anything. But because there's nothing, that is something, and that leads to the possibility of things being created. And I know that that probably sounds so stupid, it doesn't make any sense, but the concept of nothing is something. And if you have nothing, then you can put anything in nothing and it's still nothing. But anything is there, right? Everything can be contained within nothing. So our reality, I'm getting off track here, I think, but our reality is possible because the fact that anything exists at all is already an impossibility, right? But because it exists, it creates itself in both towards the future and to the past. And so It sounds wrong to think about existence in this way, but there is no beginning and there is no end, because in order for there to be a beginning or an end, there has to be a point where nothing caused it. And it just can't be. And it sounds like a paradox, but as long as you keep stretching out the timeline, the paradox continues to work. And this kind of gets into a talk that I probably didn't do, but I was thinking about doing, that was based off some comment responses that I was giving to a person about the strangeness of infinity. And so infinity is undefined. You can never get to infinity. But the point I was trying to make with the person is that infinity and infinity plus 1 are both technically infinite numbers. However, infinity plus 1 is larger. And at the end of the universe, if you got to infinity, which you never can, but if you got to infinity, you would see they're equal. But at any other point along the way, if you start at 0, right, you will always have one number greater. Because if you start both infinity and infinity plus 1 at 0, well, automatically it's 0 compared to 1. And then you step 1 this way. Now it's 1 and 2. And so no matter what, even though technically they're both infinite numbers and they are both undefined, there is no way to actually compare them at the end of the line. As they approach infinity, they are both equal. Any other point along that path, infinity plus 1 is greater. And so we are in infinity. And therefore, it does not, the concept of an ending or a beginning doesn't make any sense. And it doesn't need to make sense, and it doesn't need to exist. Because the concept of it existing is pointless. Because anytime you go, oh, now I found I found the beginning, right? You're at 0. I found the beginning. Well, guess what? Then you just keep counting down. Oh, now it's -1 compared to 0. Now it's -2 compared to -1. And you just keep going back. And now all of a sudden, guess what? One is still greater than the other. And it doesn't matter which direction you go. This is always the case, and this is always true. And you could keep counting in either direction to infinity. You will never find it to not be the case. This is the world that we live in. We live in infinity. We do not need a fundamentally probabilistic basis for reality, because if you just keep pursuing farther, there is always more. And there always will be more. And that's fine. Because we do not need a fundamental structure to understand the fundamental structure. And I went over this in my talk about looking up to understand below and looking below to understand above. Things that are much greater in scale than us can be understood by the fundamental principles of our reality. And this is entropy. This is what we observe as gravity. That's really, I think that cause and effect, entropy, cause and effect leads into entropy, entropy leads into gravity, and gravity leads into every other fundamental force that we understand. We understand everything we need to. We have the fundamental structure. That's why the Standard Model works so well. We have the fundamental structure. There is no fundamental particle. The atom was wrong. They were wrong. There is no fundamental particle. There will always be more. You will never understand if you're only looking for smaller and smaller and smaller. It will not lead to understanding. It will just lead to more questions. Understanding comes from observing what you have and connecting the dots. Rather than breaking it apart more and more, it's pulling things back together. We are trying to expand everything, But if we take a holistic view, it becomes a lot more clear. When you zoom out, it all makes more sense. The more you zoom in, the harder it is to understand what it is you're looking at. That's the problem. And I'm kind of like, I don't know, I'll probably still make a few videos here and there for my theory, but I'm kind of done. I think I've said what I needed to say. And if no one discovers my theory and it turns out that I was wrong, fine. If no one discovers my theory and it turns out I was right, so be it. If no one finds what I'm saying to be worth listening to, then they're not ready. Then we're not ready, and we're not going to progress, and that's fine. I don't really care. I would love to see us come into a more holistic view of what our universe is and our place in it. Our understanding that we are really quite small, but still connected to the whole. That the mini squabbles that we have are just so foolish. But if we're not ready for it, we're not ready. And a lot of people cannot comprehend and cannot come to terms with the fact that they are nothing and they never had purpose. They don't know what to do with themselves if that's the truth. You make your purpose. You make your value. Your life is what it is. If you can't live with the truth, then I don't know. I guess I don't know. Good luck. I don't know. I recently did a talk where I said, I'm tired of playing this game. You know, it was amusing for a time, but at this point, I'm like, I just don't care anymore. I was trying to be nice and play the game with everyone else, but I've done this. I've played this game a lot. I don't need to play it anymore. And I feel semi-crazy for saying that, but I can't help but feel it to be true. I don't want to live in the world everyone else is. And it's not saying that I'm trying, it's just such a sad world everyone's trying to live in. And everyone says this world sucks and it's so terrible. But what are you doing to change it? So many people complain about how bad things are and how bad their life is. But what are you doing to change it? The majority don't do anything. They grumble and they complain, but they still continue the march. They don't know where they're going, but someone told them they gotta walk. And I'm tired. It was fun to play soldier for a little bit, sure. But I was never meant for combat. I don't know. Peace out. So, if you believe in quantum mechanics, then I want you to think about this. Imagine you are taking my class on physics, and on the first day I tell you that there will be no graded assignments, no quizzes, no tests, no attendance, nothing. Your grade is fundamentally probabilistic. How would you feel about that? Does that sound fair to you? If it doesn't, then why not? You want your grade to be more real than physics itself? This is the argument that someone gave to me why I was being dumb, and I hope you can see why this statement is absurd. More real than physics. So basically, there was a Veritasium video that recently came out that kind of talked about how what was that? Shoot. What is that experiment called? But basically it proved, it's the I can't think of the name right now, but it was the experiment that proved that that there are no hidden variables. No hidden, I did a talk about this already. I can't think of what it's called right now. That because this experiment proved that there are no hidden variables and that quantum mechanics is actually more accurate than, or like it followed, the results followed quantum mechanics rather than the hidden variable theory, right? So assuming hidden variables, it doesn't work, right? That's what this experiment proved. And so Veritasium recently did a video talking about this, and basically what they said was that this was seen as, boom, quantum mechanics takes the win, right? And there's no other explanation. And basically this video kind of, that's how it's been, that's how I've seen it everywhere else. But this video basically went the other way and said, well, yes, it proved this, but it didn't necessarily show that quantum mechanics, boom, is the truth. And the scientist that actually did the experiment and did this was very uncertain about the results and wasn't really sure what they meant. They didn't see it as a triumph necessarily. They were kind of unsure about it. That's what this video by Veritasium, I am stumbling over my words right now, said. And so I found this very interesting because I've never heard that side before, right? Because I looked at this and I said, well, that's not proof at all. Because the problem with that experiment, which is not mentioned by anyone, what I think is relevant, is that the mathematics assumes a vacuum, right? And that's just not real. There is no perfect vacuum. And so since there's no perfect vacuum, I don't think you assume a straight, like it's supposed to be a perfect line in this thing. If there's hidden variables, it should be a perfect line distribution. But it's assuming there is a perfect vacuum. To my understanding, that's what it's assuming. And that's just not reality. It's not true. You can't possibly have that. And so there's kind of it's kind of more like this instead, right? And that aligns with quantum mechanics. But quantum mechanics is probabilistic. And guess what? When there is vacuum fluctuations, that's kind of probabilistic, right? You would have to have probabilistic. You would have to have a probabilistic distribution, and that's what quantum mechanics is. And that's why it follows that, because whether or not there's hidden variables or not, you're not in a vacuum, right? So things change, right? And so anyway, what am I talking about? I don't even know what I'm talking about. Yeah. So it was a video by Veritasium, and I made this comment on that video, and then my comment on the video was, probability is not reality. And what I meant by that was, well, that wasn't all that I said, but that was something that I said. Like I said in my comment, and then I said probability is not reality, right? And then what I meant by that is that just because the probability of something, looks like this doesn't mean that that thing is that probability. And what I mean, a better way I can say this is that when you look at the wave distribution, right, of a particle, right, there's a wave, like a particle has a wave function, right? You look at the wave function, the particle is not the wave function. The wave function is its probability, right? It's probabilistic. Fundamentally probabilistic, right? And so what I was saying is that the probability of where the particle is not reality. Just because the particle can be everywhere doesn't mean that it is everywhere, right? It's one thing to say that it could be anywhere. That doesn't mean that it is everywhere, right? It could be anywhere. It's not everywhere. The probability of it being somewhere is not the reality, right? It is not 50% there and 50% there. It is only one or the other. You flip a coin, the coin is not 50% heads, 50% tails until it lands. No, it is, how it lands is certain. It was either going to be heads or it was going to be tails. It is not a heads, tails until it lands. No. Probability is not reality. Just because you don't know what it is yet doesn't mean that it is both. Probabilistically speaking, yes, it is both. But it is not actually, in reality, both. It is heads or it is tails. That's it. That's what I was trying to say. Probability is not reality. That's what I said. And I got a comment, and I don't even know if this is a real person, right? Like, I have no idea if like these people I interact with, and for anyone that I talk to on the internet is a real person, right? And it's really hard to tell, because it's hard to tell if people are just dumb or they're just bots trying to bait me to like make me mad for some reason. And like, I don't understand why that's a thing, but I don't know if this was a real person or not. But they made a comment on they commented on my comment saying, probability is not reality, doesn't mean anything. Physics doesn't work in slogans. Or what did they put? They said, probability is not reality, doesn't mean anything. Physics doesn't deal in slogans. That's what they responded to me. And I was like, what? I was like, what do you mean it doesn't mean anything? To me, like, that statement is very clear. And maybe when I said it, you were like, what is this guy talking about? But I feel like with my explanation, if you still don't understand, then you probably should just stop watching this video, because you're not. I don't understand how you don't see like that's to be the truth. But this person did not understand. So I was like, oh, I'll just explain it to him, right? It didn't go well. And so I just kind of gave up. I was like, this is, I feel like I won like several times over in the argument, but they kept kind of deflecting it into different paths. And that's why I don't know if it was a real person or not. But I kind of just I just gave up, because it was just not worth my time anymore. Right. I was like, interesting. Well, one, probability is not reality is not a slogan. It's just a statement that I made. And I think it's also a truth. It's just, I'm not trying to make a new slogan. I'm just stating a fact. Probability is not reality. It's not. What I thought was funny, though, is they say physics doesn't work in slogans, right? But there's the famous shut up and calculate. That sounds like a slogan to me. That's a physics slogan right there, if I've ever heard one. So I said that. I was like, shut up and calculate is a slogan. Like, so physics, that's a physics slogan. And that was a thing, right? So physics does work in slogans, actually. They said they're both slogans and neither tells you anything about the physical world. And so they basically just admitted that they were wrong. But then they said neither one tells you a thing about the physical world. And this is what I mean by they deflected the argument, because I never said that shut up and calculate tells you anything about the physical world. But they're kind of deflecting the argument now because they got proven wrong, like, immediately. So that's what I'm saying. I won the argument with my first response, in my opinion. But they kind of deflected it, and I said, well, like, I don't, I was like, I don't know what you're arguing at this point. I'm like, okay, what is your argument? Neither one tells you anything about reality. I was like, okay, what are you even trying to fight me on here? I don't even know. But so I tried to explain, my argument, and um, and it ended with me like that they started kind of losing their composure a bit, because I was saying that I said I thought I took screenshots of the whole thing so I could talk about it, because I just thought that this was such an interesting conversation. But the final response they gave me, because I had said something along the lines of, in my comment, I had said something along the lines of, someone has, like, science does not progress by everyone conforming to the status quo, right? Someone has to break the mold. I said something along those lines because, by believing, like, the argument kind of shifted, and I was like, if quantum mechanics is so precise, why is it still not able to incorporate gravity? Why is it not all figured out yet? If it's so precise, why does it still break at some point, right? That was another argument that I made. And then, they said that, and I was like, so if it still breaks, then, that means there's something wrong with it, right? So if everyone keeps saying, no, it's fine, it's all good, it's perfect, right? Everyone keeps going with the status quo, even though it's not working, and we can't figure out why it doesn't work, then science can't progress. Someone has to come up with a new idea as to how it can work, right? Someone has to break the mold, right? And so I didn't even necessarily say I was the one doing this, right? But I am trying to do this, but I didn't necessarily say I'm breaking the mold. I didn't even say that. I just said someone has to break the mold. I implied that I was doing that, I guess, a little bit, but I didn't specifically say it was me, right? And this really set the person off. They started kind of cursing a little bit and they were like, what is going on in your head? Like, what the heck is wrong with you? You're not breaking the mold. You're delusional, or something. Basically they started calling me names and, like, kind of losing their composure in this argument. And at that point I was like, if you are resorting to, calling me names and stuff in this argument, to me, I think I won. And I really didn't have a response back to them at that point, because they were just calling me crazy and an idiot, and they were telling me that I'm not breaking the mold and I'm not doing anything, and I was like, okay, and I just put, like, LOL. But this whole conversation, I don't even know if this was a real person, but it was just, their final comment was just so hypocritical, and they had said somewhere in the argument, physics is fundamentally probabilistic. If you want things to be more real than the laws of physics, good luck. And I was a little cheeky, because I was like, oh, thanks for the words of encouragement. I lied, because I did say this. I'm going to do just that. I was like, thanks for the words of encouragement. I'll do just that, right? Because he was like, if you want to prove that, if you want a world that's more real than the laws of physics, good luck. And I just found that statement so bizarre to me. More real than the laws of physics. The laws of physics are fundamentally probabilistic. No. No, they're not. And I will probably die on that hill. Point at anything other than the stuff that we can't even actually see, right? Point at anything other than the fundamental building blocks of our probabilistic reality and tell me that it is fundamentally probabilistic. Point at anything and tell me that there's no cause to its behavior. That it just fundamentally is probabilistic. Point at anything, and tell me that there's not a cause for every effect. Anywhere. Point at anything other than the stuff we can't see, right? The stuff we can't see down there, the fundamental building blocks of our reality. Point at anything and tell me that there's no cause and effect, and that it's fundamentally probabilistic. It's nowhere. It's nowhere. That's interesting to me. So a world that is fundamentally probabilistic is not fundamentally probabilistic anywhere else, right? That doesn't logically track to me. If I told you that you failed my class before you even got a chance to take it, that's not fair, is it? That's fundamentally probabilistic. What's there to complain about? It's just how the world is, right? Right? If we just started killing people randomly, well, it's fundamentally probabilistic. It's just how it is. You know, I don't know what you're complaining about. That's just physics. You want to live more real than physics? It's fundamentally probabilistic. Your life is fundamentally probabilistic. You're gonna die tomorrow, potentially. I mean, who's to say? I mean, it's fundamentally probabilistic, right? To say that there's no cause, there's no effect, it's just fundamentally probabilistic. I mean, I don't know. I don't know. You could get fired tomorrow. It's fundamentally probabilistic. You could get fired tomorrow. It's fundamentally probabilistic. Who's to say? I don't know. I don't know. No. It's nowhere. It does not work like that. It doesn't work like that. There's a cause and an effect for everything, everywhere, except our fundamentally probabilistic reality. At the very building blocks, it says, oh, it's fundamentally probabilistic. Why? Why? Oh, it's just fundamentally, why? Probabilistic of what? Probabilistic of what? Why do they fluctuate? Why? Oh, it's just fundamental. Why? It's not. If it's fundamentally probabilistic, that means that there are variables at play. What variables? What variables? Apparently, there's nothing else. What is probabilistic about that? You can't have a world be fundamentally probabilistic. Because if it's fundamentally probabilistic, that means that something below that is changing and oscillating, and that's why it's varying. If it varies, something is varying, right? If the result varies, something is varying the result. It doesn't work. It can't be fundamentally probabilistic. It can't be. It can't be. And I just thought it was so hilarious to say more real than physics. That doesn't mean anything. More real than physics? How could you be more real than reality? What does that even mean? More real than reality? It's stupid. It was a stupid statement. And I'm sorry, but it was dumb. And I'm adding this person a little bit, but They deserve it because that was, why are you attacking me for saying that what I said doesn't mean anything? When that doesn't mean anything. And I'm so sick and tired of this fundamentally probabilistic idea. It doesn't make any sense. There's no logic to it. We don't know why it's fundamentally probabilistic. We say it's just so weird, but that's just what it is. It's just so weird. We don't understand it, but that's just what it is. Maybe it's so weird and we don't understand it because it's not true. Because it has no logical backing. That's why no one understands it and it feels so wrong and weird. It's because it is. Everything has a cause and everything has an effect. That's how our universe works. That's how everything is. If everything is fundamentally probabilistic, this universe doesn't exist. None of this exists. Because it's not even probabilistically possible that a world that is fundamentally probabilistic is doing anything, right? There are something else has to be changing below this fundamentally probabilistic level, right? We have the vacuum fluctuations. Why? It's just probabilistically fluctuating? No. No. Anyway, peace out.